We are given a histogram and we want to know what is the class width. So recall that the class width is the difference between any two consecutive lower class limits. Lower class limits are these things right there. So all we have to do is we just have to subtract any two of them. I'm just going to take the first two, 7 minus 1 is 6. So the class width is 6. Next one says, what is the sample size, which is the total frequency, which means we have to add all the frequencies. So the frequency of the first class is 10. The second class is between 2 and 4, so it's 3. For the third class, it's 8. The next class is 6. The next class is 4. The next class is between 4 and 6, so that's going to be 5. If I add, do it down here. If I add 10 plus 3 plus 8 plus 6 plus 4 plus 5, that's 13 plus 8 is 21, plus 6 is 27, plus 4 is 31, plus 5 is 36. So the total frequency, or the sample size, is going to be 36. Based on the histogram above, what is a frequency of the class containing the value 22? So first off, let's take a look at which of these classes contains the value 22. So 22 is going to be right up over here between 21 and 25. So we're looking at this class. Now it says, what is the frequency of the class? So we're looking at which class contains the value 22, and that last class contains the value 22. We want to know its frequency, so if you extrapolate that to the y-axis, the frequency is going to be 4. Data was collected for 300 fish from the North Atlantic. The length of the fish is summarized in the histogram below. What is the lower class limit for the fourth class? Okay, so first thing we're looking at is the fourth class. So this is the first class right here. This is the second class. This is the third class. And this is the fourth class. Now it says, what is a lower class limit? So the fourth class, we're looking at this one right here. The lower class limit is always the limit on the left. So for the fourth class, the lower class limit is going to be 72. Here's a data set. You're examining the data with the stem and leaf plot. Here is the start of the plot. We just want to finish the plot. So basically, we want to see which values have a stem of 4, which means anything that starts with a 4. So we have a 47, we have a 41, and we have another 47. So we have 41, 41, and 47. So the stem, that's going to be a 4, which we don't have to write. So, sorry, we have a 41 and two 47s. So all we have to do is, in order, we got to write the leaves, which are the 1 and the 7 and the 7. So I'm just going to put 1, 7, 7 without any commas, and that is going to be it. Here's a data set summarized by a stem and leaf plot. How many values are in this set? So remember that each leaf represents one value. Each leaf represents one value. So let's count how many leaves we have. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So unless I missed something, it should be 33 leaves. Yeah, it should be 33. So we have 33 values. And each leaf represents one value. We have 33 leaves. We have 33 values. The next one says, what is the minimum value in the last class? So the last class is going to be this one right here, the one starting with 8. And the minimum value is going to be 8 and a 2, which will be 82. And then lastly, it says how many of the original values are greater than 70. So we just want to find out how many values are greater than 70. Now, it says greater than 70, which means 70 doesn't count. So I'm not going to count that. So we have a 7 and a 5, that's a 75. We have a 7 and a 7, that's a 77. We have a 7 and an 8, that's a 78. And we have a 7 and a 9, that's a 79. Then we have 8 and a 2, that's 82. 8 and a 3, that's an 83. And an 8 and a 3, that's an 83. Oops. Keeps moving up. So how many values do we have that are greater than 70? We have 1, 2, 3, 4, 5, 6, 7. And we can also see that here. We got 1, 2, 3, 4, 5, 6, 7. 7 values are greater than 70, which means 70 is not included. The following stem and leaf plot compares the ages of 30 actors and 30 actresses at the time they won the Oscar for the Best Actor or Best Actress. So on the left side, we have the actors, and then on the right side, we have the actresses. What is the age of the youngest actor to win an Oscar? So no actors won in their 20s. Notice that this is blank. So no actors, and actors are on the left side. No actors won in their 20s. So the youngest one is going to be this person who won at the age of 31. The next one says, what is the age difference between the oldest and youngest actress? So for actresses, we're looking at the right side. Now let's take a look at the youngest. So first we got the oldest and we got the youngest. Let's take a look at the youngest actress to win. The youngest actress was this one, 21. Now the oldest was this one, which was 80. If you want to find the difference, it means we're going to be subtracting 80 minus 21, and I believe that should be 59 years. And then part C, it says, what is the oldest age shared by two actors to win an Oscar? So we're looking at actors, which means we're looking on the left side here. And we're looking for the oldest age shared. Shared, it means we're looking for two actors that won at the same age. And we're looking for the oldest. So I'm going to start from the oldest and work my way down. 76, there's only one person who won at 76. Then we got 60, we got 61, we got 62, we got 51, 55. Now, if you look over here, two actors won at the age of 56. So the oldest age shared by two actors to win an Oscar is going to be 56.